So myself, Vasu, and then thanks for Zephyr team and the TI team to host this session. We have been a long time partner for both these. As a TI as a organization, we are the platinum partner, and then Zephyr, we have been supporting Zephyr project since its beginning, from our first project called Real Board. So that's how we started promoting IoT since 2012 with our low power wireless nodes basically. So let me give a little bit of my background before we talk on the session part basically. So I started my career as a software engineer since schooling, but by the time I finished my graduation, so I had a question whether I should do a computer science masters or I should go to electronics basically. So somehow since I was into softwares since my schooling, then I decided let's go to uh, electronics. So then I started my masters of electronics basically. By the time it was like 2003, and then I have been coding in most of the languages, so that was the major decision basically, why not to do MCA but MSA electronics. So then I worked for Make Electronics, and then it was a core hardware company. In those days we were manufacturing the LED TV walls. So now today what you see from China market, Make Electronics, one of the key player, and then we were doing telecom exchange using FPGA Spartan 3 boards. Still today I remember from 2005 basically. Indeed, I developed a few of the handheld computers, 8-bit, using 8-bit microcontrollers, 16-bit microcontrollers. In those days it was Philips, now it's part of NXP basically. Then I moved my career slowly from a microcontroller to Linux, starting Atmel 8926 basically. So 9260, which is a ARM9. Likewise, Kasim sir was saying, so 2.6 was alive more than 10 years basically. So some of the ARM9 cores were also alive more than 20 years because they were launched as a MPUs, but in industry it was widely used as MCU cores. So still you could see ARM9 or MPUs which are running bare metal. You would find these cores now. Those are part of now microchip. Atmel acquired microchip, so you can find under A5D2 and all MCUs basically. So I joined Wipro and worked for Qualcomm and Nokia. So I got an opportunity to work with some SoC design teams over there, and then same thing I continued in LG basically, where ARM Cortex-A8 was my first experience in 2007 when I worked for our smart TV stack in LG, and then there were also I got an opportunity to work with RTOS, which was MUCOS. If you really see the era of 2008, 9 and all, those were the era of your MP3 players and MPEG-4 players basically, right? Like before your smartphone days basically, just before the smartphones basically, right? So those at LG we were using MUCOS 2 basically. That's what one of the most familiar RTOS which were in the industry. So there are many names in the industry which as a developers we would have never known, because those are going internally in the products. And then at those days it was this, as we are sitting and discussing internals to an RTOS, so we did not had access of those until and unless you are working in some company and share some knowledge with friends and all. That's how we come to know, right? So then so we developed the whole stack on the Linux for the complete smart TV, and then those are the products which we see in the market later with ARM Cortex-A9 and all, with complete multimedia stuff. In 2012 as today what we are seeing as a Android smart TVs and all those things basically. 2010 when I started my fourth startup called EasyArm. Basically, we were building a Linux and Android BSPs basically, and then RTOS is where we were porting. So all sort of portings we were doing on different hardwares. So there were like we come with a strong background of porting, whether it is a RTOS or a Linux or a bare metal stuff basically. So that's the a small history of FiTech India, or like a background of FiTech India basically. Today we are proud that like in India ecosystem we have launched open source hardware called RuggedBOARD basically. So it's a Linux based single board computer. So you would say how it is different than Raspberry Pi. Normally people ask, my answer is when you are done with Raspberry Pi, so you can use this basically for your products and manufacturing. So that's the small statement I help my partners to start with RuggedBOARD. So the RuggedBOARD is more of a carrier board with lot of features. Sorry if I have not tried to pull out those slides over here. So you could see our 15 years of experience, what we pulled out over here, and then like we build all the industrial interfaces on this single board, starting from all the industrial interfaces, whether it is RS485 or a CAN or Ethernet and touch display with capacitive, and then 4G modem which can be connected over PCI, which is in the back end basically. So these are the open source components which we are trying. So one side it's open source hardware, and on the other side the big communities like LVGL and Zephyr, Linux, there where we bring all together for a developer to work on a real open source ecosystem, at the same time meet the industry needs basically, right? Now coming to FiTech, as I was telling basically, we have whatever the SOM. So essentially we have been doing this system on modules since last 30 years, 35 years plus basically. When you say ARM, specifically 35 years. So we bring most of our hardware into the open source ecosystem. So here I am not listing our Linux activities. Yes, morning we had a kind of a always saying that like should we use Linux or should we move to Zephyr? So from my perspective at least, these are two different markets basically. So when you go for a MCU world, and then like I believe there are very less choices, and because of some big players, the free RTOS got into the market. Basically it's not a push, but like because of when giants adopts, basically it slowly get into the other devices, right? Like say, you know the name of the other giant which pushed free RTOS into their products. Okay, so likewise you have a very few. So we as a hardware vendor, we always have been evaluating Quantiky, Riot. These are few other operating systems when I want to work on basically. And then like Zephyr is something like which we started early, because I would say when it is Linux styled, I would say that like since I am a Linux developer, always I do push. I know the kind of challenges for the microcontroller guys who want to adapt these RTOS because of again the way, or the as a pure embedded guy, as always, what are the registers which are important to configure to get our output or to get our things done. But essentially then you start putting a software architecture story on top of it to make it more generic, more scalable, adaptable, basically, which keep taunting at least the electronics guy, if not the computer science guy, basically. So there where always a fight happens between in the embedded world, basically, right? So for us, very few choices were there in terms of practicality, because we were launching a lot of our industrial IoT modules, and then like we have to choose some of the RTOS. So Contiki was one of the choice, mainly because of the support of wireless stacks, basically. On the other side, free RTOS, I know I know free RTOS from the days when it started as a four file operating system. Still, I think it's somewhere there, basically, right? So when Zephyr started, since it's a Linux foundation, it has to be driven a community way. That was the biggest promise we thought, like to take on and then start contributing from Phytech, and then like also we started supporting our customers to build their products using Zephyr, basically. So we have our major product lines from MPU, but all the MCUs. So it's all about, as I told, IoT. The story at Phytech for Zephyr has started because of IoT, basically. And then in IoT, we need to take you have a gateway or the microprocessor component, but essentially when you define IoT is more about your low power devices, and then like sensors, the number of sensors, basically. So there we positioned Zephyr as one of our standard open source platform, basically. In this slide, what you are seeing again, the other story, what is not a pure microcontroller, but a MPU plus MCU, basically, right? So I would bring in a couple of use cases which might be sounding interest why to use in this this scenario, basically. Not always, but like what could be the use cases or the applications. Okay, so for one of my partner, they want to run, so they have a very stable wireless stack. They have a very stable wireless stack which is already developed in MCU, and it is running for a long, and they don't want to adapt some open source standards like Bison or Zigbee and these standards. They don't want to do, because their existing system is there, right? And then they don't want to again put or migrate it to the Linux. But as a part of gateway, this stack has to run on a Linux computer. Now, traditional way, what we do is we bring in the microcontroller, we connect it through SPI as a device, and then like we start running the things, right? Like, so you have a network. Essentially, in our terms, we would call it as a network coprocessor, which will run the stack, do all the wireless part of the play, and then bring it to the microcontroller through SPI, mainly for the interprocessor communication, basically, right? So now, in such scenarios, basically, this could be one of the best use case, wherein which we are having a Zephyr on your MCU, whether it is a M4 or a M7 or R5, basically, and then you run the stack. It's not only the small peripheral interface, but like you are running whole of your software stack on top of that, basically, right? So this is one use case. The second use case which a lot of our partners are implementing in this scenario is there are a lot of, when you go for a US or Europe market, it's full of standards in terms of like, say, like how CAN has evolved, or like how EtherCAT or like Profibus and all, basically. So there are n number. Slowly those things are coming down, but still people want to have their own innovations to be in their specific domain basically. So where they want to develop a lot of industrial protocols which need to be again executed on a MCU, not really on the, so they don't want to bring it as a part of Linux. So again, it's a kind of a coprocessor architecture where the whole of the stack, the industrial communication stack, would be running on your MCU, and then you use Linux as a master controller basically. So in that cases basically, so some of our partners we have been supporting the same architecture, so where the Linux runs on MPU and the Zephyr runs on MCU part basically, right? So this was our first project with Zephyr, where we developed our IoT platform. So we called it as a real board to promote mainly on the IoT ecosystem basically. So where you could see the low power display basically, e-paper, and followed by a lot of other sensors on the board. And what we did a small modular architecture where we can replace any of these MCUs. So essentially, as I told, so we started since 2012, we started this low power module development, mainly to support, it's not our core business, but to really support our existing customers and also to implement industrial IoT applications basically. So we started, so few of our early was CC2650 was BLE and sub-gig microcontroller by TI basically, and then we had KW series of NXP, and we also supported Renesas and other microcontrollers for these, and Nordic. So when I'm talking all these names of SOCs and all those things, you would see that we are trying to bring device agnostic framework. So now one side for the application developer, you have your Zephyr, which is a single platform, and on the other side, depending on the need and business criteria, basically the product companies can choose their as different hardwares basically. Now coming to the specific once we had this Zephyr as a selected RTOS basically, then we thought why don't we support our existing partners who have been using multiple GUIs from different cluttered way basically. If they are using Renesas, they use a Renesas library. If they use a microchip, they use a microchip library of graphics basically, of if they are using NXP. So there was a cluttered market in terms of HMI for MCUs. For MPUs, at least we are very sure that we have been supporting QT more than 2 decades basically, more than 2 decades, and then we have been, so QT is something which is a industry de facto for a HMI on top of Linux. Yes, they have now versions of MCUs basically, and then they have a kind of you have a licensed model to work on basically, but Qt started with also a community approach basically. So LVGL is one of the beautiful graphical stack, I would say, which is developed, or when we develop the UI basically, so it is exporting the whole of the UI, user UI, into a C libraries or the C code. Then you integrate with your application code, which is written in C or C++ or so. So the way it has been designed, and the selection of the LVGL by our team has been started because mainly of embedded friendly architecture basically. So now when I say embedded friendly architecture, you always want to have a control of the things what you are developing, and then when it is little bit on the C or C++ side and all, so you are always feel happy to have those things, right? Especially on the microcontrollers. So so specifically on this project where we took RA8 by Renesas, which was a new microcontroller by them, Cortex 85 basically, M85, which was basically supporting a very base base port of Zephyr. We didn't start it from zero, but at least we can say the level of 3 or 4 we can start. We have started, but integrated all the peripherals of RA8 into the Zephyr, and after porting the Zephyr, after bringing up the Zephyr RTOS itself to this RA8 platform, then our team has integrated the LVGL on top of this build. So today we have a complete build of Zephyr plus LVGL for the HMI development basically. So wherein which earlier we were, so LVGL was not new for us. So LVGL we have been using with our Linux platforms also, but this was our first project, which LVGL is a very lightweight graphic library, which was meant for catering again starting from MCU till MPU level basically. But initially we have supported in our TI and NXP MPU platforms, basically IMX6UL, IMX8M Plus and AM62. These are the kind of platforms where we have supported LVGL, and then our team, what we as a HMI, mainly from a HMI perspective, we wanted to support on a microcontroller, because the microcontroller ecosystem itself is growing today. I do remember my microcontroller when I started is 30 megahertz, and 30 megahertz with 8051 core. Today you have MCUs which are clocking at 1 gigahertz basically. So all your Cortex M7 and M8 and then like M55. So there are the definition of microcontroller itself is changing basically in terms of the stack or in terms of the applications basically. So if you see the first personal assistants, voice personal assistants basically, like Amazon Echo and all, when you see, so those were based on Linux. But now you could see that like those, because most of the voice processing happens over internet, so now you need only a audio streaming capability with a strong like audio filters or DSPs a little bit on the things, so which is already part of your earphones. So you would see the latest super duper earphones which or headphones which you are buying for like say 15-20,000. Last 6 months back my kid bought 9,000 rupees a headphone. I would say I would never buy in my lifetime. Right? So where you see that like these are microcontroller things which the technologies has been already implemented and adopted basically. So now for the microcontrollers to do these kind of application is not new. And now when these kind of applications are coming, we need more and more stacks which are really required basically. So I would like to pop up one of these. One minute, sir. Let. So, yeah, sir. Yeah, you can. Okay. So you could see, I don't know how clear it is visible for the last row people, right? So now when we see from the architecture, it's not only a small RTOS of four files basically. It's all about the software ecosystem in terms of the stacks basically, right? So this is what like we gain the trust of Linux, because if I can copy the style of Linux, like in terms of the coding, in terms of configuration system like kconfig or so basically, right? Why can't I derive my small other modules from Linux? So there where the trust is growing up. So the trust is growing up from the different stacks which are slowly enabled for the MCU ecosystem. So still I want to bind it to the MCU ecosystem. So let's draw a clear line: MPU Linux, MCU Zephyr. That's where a clear line, at least at Phytech we do follow. Basically, it's not necessarily has to be followed by everyone, but for us to make a small decision, a quick decision basically. So we do that, and then like when you say MCU, there becomes, you go to each vendor, each vendor would provide you his own network stack, his own file system stack, his own BLE stack, right? Like say what Kasim sir was also highlighting, right? Like as a community we have to bring the more common infrastructure which can be utilized by large number of audience, so that the component becomes more reliable and trustable. In the space of open source, the more and more trust we build, the more and more it is adopted by the market basically, or by the real product manufacturers. So today if I have an answer saying that there is a very strong BLE stack available in Zephyr, then merely 50% of healthcare devices which comes in future are covered, right? so that's how we bring. So there is a kind of a very specific LVGL session we wanted to do, but because of time constraint we couldn't do. My developer Vagish is available over here, who worked on this complete project. So in case of any specific technical questions in terms of this project you want, like he could be able to discuss with you and share his knowledge. This platform, indeed we want to offer it as an open source. So there is a big, yeah. So anyhow, he is also a part of panel discussion, so probably he will be available whole day basically. So these are a couple of use cases which we wanted to bring from our customer perspective, where we have been it has been heavily used with Zephyr RTOS basically. So LVGL, there is a small demo we have kept. Probably we will set up on the other room because we have the tables basically, so you can look and further little bit more technical details and presentation on LVGL. We wanted to do a specific UI hands-on sessions basically. So in case if some of you guys are interested, so you can ping us, and then we would be happy to do that hands-on session also with selected groups. So now open for questions. So it's in progress actually, so it's not really in compliance basically, but there is a group, security group dedicatedly running working on this. So we are also part of that group and trying to see that like how soon we can bring it basically. But yes, it is working in that line. So see this safety critical is two different stories basically. One is from your process driven basically. So now when I say process driven, so the development environment or the your documentation, your platform, so the whole company or a small group of your team who are working under this project need to follow a stringent process, and they like your ISO things basically. It's a small practices we would be doing normally in our company, but we don't document, or we don't say like we don't follow them say 100%. We follow them 70-80% as a habit, but not as a process basically. So the documentation, one is on a technical side there will be contribution from the community, but the documentation and the process has to be part of the partner basically. And there were like space of all the commercial RTOS lies on basically, right? So so where they maintain all these things for you, and like you just take Green Hills, or like you take QNX, so you have this. So obviously this will not replace the baked food of your safety critical or certification, but technically it will support. Today, even when I develop a hardware, customers say, Vasu, do it is a CE certified, FCC certified. I say, technically you won't have any issues. I will give pre-compliant tested in the lab basically. If any problem comes, I am there. I am responsible basically. From a developer perspective, always you will take a technical challenge rather than of a certification process and all those things, which has to be done by the end customer basically. And until and unless there is some commercial wing or some company who adopts Zephyr and do those things and offer as a safety critical part, I believe that will remain the same basically. So one is the technical and the second is the process. Yes. So consider in a layman way basically, you consider it as a whiteboard basically, right? Like, so where you change the polarities of a electronic device to look different. So now you on a white surface you have all the pixels basically, but you have changed the polarities, which is shown as a black, or like now there are color e-ink displays also. You change the polarity, but these polarities you don't need to refresh. To be in the same polarity basically. So now what you do, if you remove the power, it remains the same. So in the e-ink, once you have programmed basically, it's like electrical EEPROM basically. Once you have written some data, until you erase it, it will be visible the same basically. So the same concept over here. So it is a passive display. So in order to change the data, you need the power. Otherwise you remove the power, it's still available basically. No, these are, see, the application itself is a different. So these are not really used as a HMIs, but like they are used more on the data which has to be statically displayed. So the most retail application of e-ink, if you see basically, is the label displays. So label displays in marts or in anywhere basically. So where, because you want to put normally we have our sign cards with our e-label, this one same board basically. So the use case itself is different. So where you don't change the data quite often. Think of a supermarket, hardly like if the price changes anytime in a week, you have to change. Otherwise, the same price tag with all the other static data will remains the same, basically. It's mainly meant for low power. So you really don't need the power. So once you program, cut it off. Cut the power for the display. So any other queries? Okay. So let me ask my queries then. So how many of us are Zephyr developers? Sorry, it's a stupid question. Okay. Yeah. So how many of us added a new file with a configuration? Configuring the, like say I'm adding a small feature, say display feature or a display driver, e-ink, let's suppose in this case, basically. So we have added a e-ink display driver. There could be a multiple displays, right? Like e-ink displays, I could have like five vendors basically, and then maybe the core part we have written SPI and then little bit of the data writing and data, but like there are interface configurations we have to do differently. Let's suppose we have 5 different e-ink display files, drivers basically. Then we have to add and we have to provide a configuration to select one or the other display. So what I mean to say is just adding one, forget about these also, adding one file in Zephyr and make sure that like whenever a developer need, he will enable and compile the Zephyr, so he have that, otherwise it could be disabled. Yeah, board package. Okay, yeah, it's a kconfig. So why I'm asking all this is basically we always have these MCU guys moving to Zephyr. So these are few things which are like always is a kind of steps they want to learn. It's really, why I'm saying is there's just a half day or a few hours job which MCU developers need to have some 4 or 5 steps need to be learned from the Linux, which makes them very comfort on using Zephyr. Okay, so typically I teach the whole Linux kernel handling, means porting and the code flow and all those things in half a day. I used to do since like 2010, right? So all my developers are built in house, so they learn all these things. So when the microcontroller guys moving to Zephyr, so there are few like kconfig, little bit on the code flow, because when we are writing MCU bare metal, we will always do our own flow. But when you are slowly jumping into the RTOS or so, better you have a code flow basically. So one is code flow, the second one is the build system, the third one is the driver structure to be attached morning, as was been discussing, right? Like we have to strengthen the rules to integrate any components. So if the second speaker is ready, I will stop. I'm just killing the time. Okay, so the organizers. So you don't sit for so please stop me. So kconfig is one of the small easy part. If the microcontroller guys spend for like a couple of hours, basically you will get hold how to play around with Zephyr. So whatever this block I was showing basically, So now think you could count the number of blocks, right, basically, and each block is bringing many files. Yeah, nowadays it's okay, like you get CC Studio or Simplicity Studio by each vendor or each microcontroller vendor would give you some studio, and then like you click and all the files are added, basically, right? So there were it was at least not available for us, where we were Kill compiler, Kill IDE users, basically, and IAR Studio or Kill. So now each of these block will bring a lot of files. Now this file handling can be done with a very small exercise, with a very small exercise of couple of hours, basically, which is called kconfig, and then you can come to know that like which block and how to, means at least which file or which feature to be used. That is what a small common thing which I wanted to give as a advice, basically, as the journey started for us, at least as a Linux developer to a Zephyr developer, basically. Yes, sir. So typically, if you really ask me, basically, I never used any tools or any these things, basically. But on a high level architecture, now if you see over here the architecture, basically, so high level architecture, how it start is with the startup code, right? So first you start with your startup code of any operating system, not only for Zephyr or Linux, basically. You start with the startup code. The startup code jumps to your main file, right? And then main file, the beauty with the Linux is basically now it has been structured. So now after your startup code, it threads to kernel, and then in between the kernel initialization, it starts with the device. So now your SOC is also the starting point of the device, basically, right? So there were in Linux you have platform devices, basically. The platform devices are like kind of object oriented or abstractions, basically, for your components. So now if I want to Bluetooth component, or if I want to, like, say, storage device or a USB device, basically, so here what you do, you have a startup code, you have a board file, basically. Now how board file is connecting to your hardware independent and hardware dependent, very simple. After your startup code, it will thread to two threads, main threads, basically. One hardware dependent and another one is hardware independent. Hardware independent is all my OS core, which is responsible for your, like, process management in Linux, I'm saying, basically, right? Okay, so process management, your memory management, your device management, basically, right? Network, again, network comes as a one component, sub-component. So essentially, for if you are doing the BSP side, the board side understanding will be good enough, basically. And then, like, you have to see in each of the operating system how the modules are integrated. My file system, how it is getting integrated. Like, run one basic device driver, you will get to know. One basic device driver, if you write, you will get to know how the module are inserted. Typically Linux kernel modules gives that part. So in Zephyr, basically, I'm not a Zephyr developer. Maybe my developers would use that. In Linux, normally we have a top command. So similar kind of utility should be available in Zephyr, basically. Yeah. Okay. Thank you, guys.